I think I saw one.
So if you look around this region near the light, you'll see these little squiggly lines that will start to eject from this little thorium source, which is a radioactive element. And it's fairly weakly radioactive, but you'll see, if you look at this, you'll see lines that are going to be coming from it. They're very faint because of the image quality. So that was like an alpha decay. You'll see a little bit thicker. They found out people are watching. Yeah, that was fun.
Yeah, although this setup is super simple. This was like state of the art, basically, particle detector technology, basically, in the early 1900s or up to mid. And it got better in the mid 1900s, but it was only basically they had automatic systems to take photos of it so that you could when there was a good track and stuff. So people would just use these films and then even now you can go to particle physics labs and they can just give you these films of old particle detector experiments that are just a bunch of cloud chambers like this. They have tons of tracks in them, and people would by eye figure out, oh, that track goes like this. That's an alpha particle and whatever. So yeah, super cool.
Yeah, and these actually weren't made to detect particles. They were made to find out how clouds work. So the person who invented it, he had a hot air balloon that he went up on, and he went high into the atmosphere. But he noticed that there were some trails that were left in the clouds, similar to these, but much thicker and much more defined. And they're actually high energy cosmic rays coming from space. So that was the first recorded detection of a high energy gamma ray.
Yeah, and I can definitely see some particles that I think are cosmic rays, because they're not coming from the source.
Into it.
So if you see a particle that's not coming from here, or then that's just a cosmic ray. That's just a particle that is created in our atmosphere and just is passing through. They happen much less frequently, guys, at the 10%. So probably only expect to see one every couple minutes or something like that. Any other questions on this? I have a few more slides.
Why is the pin in the middle there?
Kind of just to give it an equal path length, so it could decay from any side of the little
circle.
circles.
That's where the particle travel from.
Exactly. Yeah. So if we
Wow, there's a lot of them.
Side, you may not see it be. You might not see it decay.
It's a lot hard. If people want to come up and look on the screen, actually, if you guys want to come up and look on this screen, it's a lot easier to see. There's a ton.
Yeah, nice.
It's just hard to tell on the projector. Yeah, you guys can go ahead.
Yeah, we also have a poster that the high schoolers made that worked on this with me, and also another graduate student, Tony. We co-mentored them, and it was pretty much, they sat in the lab with us to give them tips, and if they needed help soldering something or troubleshooting a component, we would help out with that. But yeah, this was an independent research project that 2 high schoolers got to complete. Pretty awesome.
maybe we can wrap up.